Talking about kinetic energy, the first formula that comes to mind is, of course, the more well-known 1/2 mv squared. Now, we want to, what if we decided to derive this? Well, we know that v squared is equals to v dot v. So we can rewrite this as 1/2 mv dot v. Now let's derive this in terms of t. So d over dt of k equals 1/2 m and then product rule. So we have to derive the first one. So the first one will be v dot times v plus the second one, so v times v dot. Now this one becomes pretty easily. Let's write k dot, of course, because it's the terms of t, derivative in terms of t. So we have 1/2 m, and then this is twice the same thing. So instead of writing v dot v plus v dot, we can simply write 2 times v dot v, close parentheses. So we can get rid of the 2's right here, and with that, we get that the derivative of the kinetic energy in terms of time is equals to m v dot v. But we know that in our case, v dot is equals to acceleration. This means that, so we know that instead of writing v dot, we can write a. So let's rewrite it the same way. We have m times a times v, and that's the derivative. Now, you should immediately see that this ma is equal to something that you already know, which is equal to the force. So in our case, we get that the derivative of kinetic energy in terms of time is equal to the force times the velocity. Okay? And that is pretty straightforward so far. Now, though, let's remember that ke dot is equals to d of ke of dt. So let's rewrite it in terms of d and dt. So we will have d ke of dt is equals to f times v. Oops. So we can use the normal way, and we take this on the other side, this side right here. So we have d of k integral equal to integral of f times v dt. So we derive it, and we get k on this side, of course, and then f v times t. Now, you can see immediately that v times dt, v times t is equals to x, like we was done. So we can say that kinetic energy is actually equals to force times displacement. And we just derived the terms of the work kinetic energy theorem.